Hi everyone. Today let us see few more numericals on solution of homogeneous linear differential equation. So let me take this numerical. So this can be written using differential operator. So let me write this using differential operator. So it is d cube y plus y is equal to 0. Now let me simplify this further by taking y out. So this becomes d cube plus 1 into y is equal to 0. Now auxiliary equation for this is m cube plus 1 is equal to 0. So this is the auxiliary equation. So now auxiliary equation, if you see, we have to find out here 3 roots. Since it is a cubic equation, we have to find out 3 roots. So let us find out 3 roots here. So in my previous video, I have told you how to calculate the roots of the cubic equation when we calculate the solution for third order differential equation. So let's see. So it is m cube plus 1 is equal to 0. So let me find out first root by inspection. So substitute m is equal to 1. So m is equal to 1, if you substitute, this gives you 2. So the equation gives you 2. So which is not a solution, which is not satisfying, So this is not a root. So let us try with m is equal to minus 1. So let us try with m is equal to minus 1. You can also try it with 0 also. If you are getting 0 everywhere, then it will be satisfying the equation, then it can be a root. But here substituting 1 over 0, if I suppose substitute, this will be 0 plus 1. So I am getting 1 as an answer, which is not satisfying the complete equation, so that will not be the root. So m is equal to minus 1, if I substitute, this gives me equation gives minus 1 cube plus 1, which is nothing but minus 1 cube is minus 1 plus 1 is equal to 0. So m is equal to minus 1 as one of the root, is a root. So now we need to calculate 2 more roots because it's a third degree. So 2 more root we need. So let us go for synthetic division method. So what we do is, I've told you how to carry out synthetic division method. So we'll write from the auxiliary equation, that is m cube plus 1 is equal to 0. The coefficients will write here. So coefficient of m cube is 1. So let me write here. Next, we don't have m square and m term, but we have to write the coefficient. So if terms are not there, the coefficients will be 0. So here in this equation, m square term is not there, so the coefficient will be 0. Similarly, m term is not there, so the coefficient will be 0. And we have a constant term, which is nothing but 1. And according to the procedure, we have to add 0 to the first number. So this gives me 1, and here we have to write the first root. So first root we got minus 1. Then you multiply this with this, then you write the product over here. So after multiplying, we get minus 1, then you add these two, so it is minus 1. Then again you multiply this with this, so it is minus 1 into minus 1, that is plus 1, and you write it here and you add it with this, so it is plus 1. Then again you multiply this with this, so you are getting minus 1, you add it with this and you are getting 0. Now we'll write the equation. So we write the equation, so it is 0 over here, so this will be the constant term. So let me write from this side, so it is plus 1. This will be the coefficient of m, so minus m, since it is minus 1, minus m plus m square minus m plus 1 is equal to 0. Now let us solve this. Now it is difficult for us to factorize, but we can go for the method which is nothing but, if you remember, the roots can be calculated as minus b plus or minus square root of b square minus 4ac divided by 2a. This is a basic algebra equation to find out the roots. So from here a is coefficient of square term and b is coefficient of this term and c is the constant. So here let me write the roots. So m will be equal to minus b. So it is minus of coefficient of b is nothing but here minus 1, that is coefficient of m. So b is nothing but coefficient of m. So it is minus 1 plus or minus square root of b square. So b is coefficient of m. So it is minus 1 square minus 4. A is coefficient of m square, that is 1 into c. C is constant term, that is 1, divided by 2 into a. A is coefficient of m square, so it is 1. So we have here 1 plus or minus square root of 1 square is 1 and this is minus 4. So 1 minus 4 is minus 3. So it is minus 3 by 2. Or I can write this as 1 plus or minus square root of minus 3 is root 3 I can write, or this can be, if you take this can be written as square root minus 3 can be written as square root 3 into square root minus I. So square root 3 square root minus 1 square root minus 1 can be written as I. So it is square root 3i divided by, there is 2 over here, so this. So the m roots are now half plus or minus root 3i by 2. So for this equation we have 3 roots. So one is m is equal to minus 1 and we have pair of complex roots, that is a half plus or minus root 3i by 2. So the solution will be y is equal to, let me write the solution here itself. So y is equal to, first is real root. So we write c1 e to the power minus 1x, that is minus x, plus the other two roots are complex, pair of complex roots. So let me write e to the power ax. So what is a here? This part is a, this is b. So half x into c2. I am using arbitrary constant as c2 because c1 is already used here. c2 cos this, that is root 3 by 2 x plus c3 sin again root 3 by 2 x. So this is the solution. Let us see one more numerical, which is with the fourth power differential equation with fourth order. So let me take 4d to the power 4 minus 4d cube minus 23d square plus 12d plus 36 into y is equal to 0. All these numericals I have taken from Dr. KSC Engineering Mathematics 2 textbook. So you can refer the solution there also. I will be doing few more numericals from the exercise 2. So let's see that later. So we'll see few worked out problems. So this is a differential equation. So let us write the auxiliary equation for this. This is already written in differential operator form. So let us write the auxiliary equation for this. So 4m to the power 4 minus 4m cube minus 23m square plus 12m plus 36 is equal to 0. This is the auxiliary equation. Now we have to find out the roots, and we know that there are 4 roots for this particular equation. So we have to find out 4 roots. So let us start with by inspection method first. So you can start substituting different values for m, and you see whether it satisfies the equation. If it satisfies the equation, then it is a root. So you start with 0. So if I start 0, if I start substituting 0 over here, then this will be 0, this will be 0, this will be 0, this will be 0, and we have 36. So it doesn't satisfy the equation. So it is not a solution. So similarly, you substitute 1, minus 1, then you substitute 2, minus 2, and so on. So by doing this, I can find out if I substitute m is equal to 2. M is equal to 2. So let me see what I'll be getting. So it is 4 into m to the power 4, that is 2 to the power 4, minus 4 2 cube minus 23 2 square plus 12 2 plus 36. So this gives me 4 into 2 to the power 4 is 16 minus 4 into 8 minus 23 into 4 plus 12 into 2 is 24 plus 36, and this gives you 64 minus 32 minus 92 plus 24 plus 36. And if you simplify this, you will be getting 0 as answer. So m is equal to 2 will be root. Is a root. So now we have already found one root, but still we need 3 more roots. So we'll see how to calculate that. So let us use synthetic division method. Synthetic division method for the remaining 3 roots. So from the auxiliary equation, let me write all the coefficient. If any of the term is not present, but still you have to write the coefficient of that term, saying it is 0. Okay, now here all the terms are present. So let me write the coefficient. So we have 4, then we have minus 4, then we have minus 23, we have 12, and we have 36. Okay, let me start with this synthetic division. So 0, I am adding 0 here, and the root, first root I have to write here. So it is 2. So you just add it with this. So it is 4. Then you multiply with this. So it is 2 into 4 is 8. Then you add it with this. So this gives me again 4. You multiply with this, and this is 8 over here. So you write it here. Add it with this. You will be getting minus 15. And you multiply this with this. You will get minus 30. You write it here. And if you add these two, you will be getting minus 18. And you multiply this with this, it is minus 36. So let me write minus 36 over here, and if you add, you will be getting 0. Now you try to write this in the equation format from starting from here. So this is a constant, so minus 18, the previous term will be for m, so it is minus 15m, and this will be for m square, so it is plus 4m square, and this will be for cube. So it is plus 4m cube is equal to 0. Okay, so we got again a cubic equation, but again we have to find out 3 more roots. So what do we do? So again you see, use by inspection method, you see any is there any root? So you substitute and see. So if I substitute different values for m here, I'll be getting different values, and if I substitute m is equal to 2, then it satisfies the equation again. So you see 4 in 4 into 2 cube plus 4 into 2 square minus 15 into 2 minus 18 is equal to 0. So this is 8 into 4 32, not 0, sorry. This is plus 4 into 4 16 minus 30 minus 18. So this is minus 48, this is plus 48, which is equal to 0. So you have again 2 as the root. So we'll again go for synthetic division method, but this time not from the previous equation. We have already done once with the synthetic division here. Now we are taking this as a equation. So write the coefficient from here. So it is 4, it is 4, it is minus 15 and it is minus 18, and we have already found out one root over here, it is 2. Okay, so we'll add 0 with this and it is 4, multiply with this, it is 8, add with this, it is 12, multiply with this, it is 24, plus 24 minus 15 will be 9, multiply with this, it is 18, and add it with this, so it is 0. Now you try to write the equation for this. So the equation from here, I'll write it over here. So it is a 9 plus 12m plus 4m square is equal to 0. Now you try to simplify this. So simplification, direct factorization can be done. Direct factorization can be done. So let us see how to write. So 9 into 4, 36. So let me use one more paper. So it is 4m square plus 12m plus 9 is equal to 0. So factorization, 4 into 9 is 36, and the product you need to get 12. So which number gives you 36 as the product and sum, this is sum as 12. So we have 6 and 6. So I can write 6 here and this is 6, product will be 36 and sum will be 12 here. So there we go. So it is 4m square plus 6m plus 6m plus 9 is equal to 0. Then you factorize. So from these two, 2m can be taken out. So 2m. So here it is 2m plus 3. And here from this, 3 can be taken out. So we have 2m plus 3 is equal to 0. So it is 2m plus 3 into 2m plus 3. So we have two roots from this, m is equal to minus 3 by 2 and also m is equal to minus 3 by 2. So altogether we have 4 roots. One is here, m is equal to 2. Then again after this, again once more we got m is equal to 2 with the after first synthetic division. And again we have two roots which are minus 3 by 2 and minus 3 by 2. So we have 2, 2, minus 3 by 2, minus 3 by 2. So for writing the solution, if you see here, there are repeated roots and also distinct roots. These are same, these are same. So let us write the solution for this. So y will be equal to C1 plus C2 into e to the power 2x, this is for repeated root, plus I am using two more arbitrary constant, that is C3 plus C4 x, x is there here, x e to the power the other root, that is minus 3 by 2 x. C1 plus C2 x e to the power 2x plus C3 plus C4 x e to the power minus 3 by 2 x. So this is the solution. So these are the same roots. So we are using C1 plus C2 x e to the power that root into x, and since we have other real and distinct, so twice we are using the same thing. So this is the solution. Thank you.